Hi, welcome to Watkins Waggles. We're talking about what the possible 6 markers might be for C2 chemistry. Now you've got to remember first of all that the 6 mark question is always the same question, whether it's the foundation or the higher paper. Now because foundation can only be up to a C grade standard, that means your 6 marker is never going to be harder than a C grade question. So first piece of advice, don't overthink it, don't try and make it harder than it is. It's only going to be a C grade standard, and it doesn't have to be a huge effort to get yourself those 6 marks. On the screen you can see that there is all the 6 mark questions that have existed in the last 5 years, but also this is the whole time the specifications existed. So 2016 and 2015 were very similar styles of questions. They gave you a load of information that you'd not seen before, and you had to actually go through and explain what it showed, using the data they gave you and using all the skills that we've taught you, describing patterns, starting with statements like as the, as one thing increases, does something else increase? Do we end up in a situation where there's an anomaly? Is there a change in pattern partway through? And possibly having to use some science to explain those patterns. Those questions should be quite straightforward. You simply use your skills, you do exactly what you're told, and you quote some of the data that they've given you. Before 2015, the questions did rely on your knowledge. Now if you look at the words in bold, 2013 and 2012 both had the requirement for you to write a method. That was a few years ago. It hasn't come up for a while. And the exam board seem very keen on your ability to write methods. That's where my money is at the moment, that you're going to be given some apparatus or a description of an experiment, and you will need to come up with a method either to investigate something, so changing a variable, seeing the effect, or a method, for example, to make a salt. We'll look at those in just a moment. Finally, you can see that electrolysis came up in 2013 in January. Now, there are 2 types of electrolysis cell that you were given, stuff that you wouldn't have seen in lessons. So we've got 3 years out of the 6 where they've given you information that you wouldn't have seen before and you're expected to use it. Be ready for that. Okay, nobody in the country will have seen that data or that experiment before. They do that on purpose to make sure that you can use your knowledge. So just go with your skills, do what they tell you, and try your best. If you look at 2014, it very much relied on your knowledge of structure and bonding. In this case it talked about chlorine and sodium chloride and why they were a gas or a solid at room temperature, and you had to know your facts. But luckily, a simple list of statements would have got you full marks quite easily. So first of all, we're going to look at the methods. What do I think are the 3 things that are going to come up in general for 6 markers? And with this method question, how are we going to answer it easily, quickly, and with full marks? So as I said, we're trying to take some bets on what we think the 6 marker would be. Obviously, we hope that you've prepared absolutely everything, so that no matter what came up, you are going to be able to answer it. But obviously there's a limited amount of time left, so you've got to try and be a little bit clever about it. Now, I don't have any magic formula. I've got no idea what is going to be on that paper. This is just an educated guess. Now that I've put it down on paper, chances are it won't be any of these 3, but it'd be daft not to prepare them. So I think that our 6 marker could be a method. It could be looking at covalent bonding, structures and properties. There haven't been any longer questions on this for a little while. This is things like your graphite, your diamond structure, maybe simple covalent structures like your water molecules, oxygen, that kind of thing. But also remembering that silicon dioxide has a really similar structure to diamond, and the exam board do expect you to know that. So whenever there's a question about silicon dioxide, or it looks a little bit like a structure of diamond, treat it exactly as if it was. Finally, electrolysis. Sodium chloride solution, or brine, is something that you have to know about and the electrolysis of it. It doesn't come up as often as aluminium oxide electrolysis, so that could well be something they could ask you to maybe describe and explain, talk about the products made, and talk about what those products are used for. Don't be put off. You do need to remember that your 6 marker can be bullet points, as long as they make sense. It could be a table. If you were asked to do a comparison, you could put advantages on one side, disadvantages on the other, and it'd be totally valid to get you 6 marks. So, writing a method. What are we going to have to do if that's our question? First of all, there are 2 different types of methods that you could be asked to write. The first type of method will be an investigation, probably into the rate of a reaction, so the speed that a reaction is happening. Because it's an investigation, there is going to be an independent variable, something that you are going to need to change. And including words like independent variable and knowing what they mean is always going to put you into that top bracket of trying to get 6 out of 6 marks. First thing you'll need to talk about is things that you're going to have to measure. Don't use the words like record or write down or work out. The key word is measure. So you're going to measure the time that reaction takes, usually from the start to the end of the reaction. And you're going to have to explain, when are you going to need to start that stopwatch? When are you going to need to end the stopwatch? You must make that absolutely clear in your method. In order to measure a rate of a reaction, like a speed, speed in physics is distance divided by time. We don't have a distance, we definitely have a time, but instead of the distance, we're looking at a product being made in the chemical reaction, or one of the reactants being used up. So you'll need to talk about what are you going to measure and how are you going to measure it. You must make sure you state exactly what it is that you are going to be measuring in that experiment. I keep using the word measure. Remember it. Use that word. That's on our mark schemes as examiners. That's the word we're looking out for. So if it was an experiment that produced a gas, then obviously you could measure the volume of gas that is released in a set amount of time. If the reactant, for example, was going to be used up, if it was going to disappear, because maybe it started off as a solid, like a metal, for example, in an acid, then you can time it takes for that reactant to disappear. Some of our reactions that we've seen involve a solution that goes cloudy. And in order to time how quickly it goes cloudy, we can put a cross underneath the beaker and time how long it takes for that cross to disappear. So the first thing you need to state is what are you going to measure, exactly how are you going to measure it, in order to make sure that you've got enough data to work out the speed. Make sure at each stage you name the apparatus correctly. Apparatus, they use that word a lot in the exam. You just need to think the apparatus means equipment. Okay, which practical bits of kit am I going to use? Is it a conical flask? Is it a pipette? Make sure you've reminded yourself about the names of the equipment and use their correct names. It's something else that gets you 6 marks. Right, is there a variable that you're going to need to change? Have they asked you to investigate, for example, temperature? Have they asked you to investigate concentration of one of the chemicals? You must make sure that you simply state that you're going to repeat the investigation, whatever you've said you're going to measure and however long you said you're going to measure it for, but repeat it again, but changing that variable. So it might be repeat the experiment, but this time use a water bath to change the temperature of the reactants, or repeat the investigation, but the next time use these different concentrations of your acid or an alkali or any other named solution. Everything else in the investigation must stay the same. So keep any other concentration, any other volume, any other mass exactly the same unless specified. Please notice I have not used the word amount. If you use the word amount, you could mean a concentration, you could mean a volume, you could mean a mass. And the examiner is not allowed to decide what it thinks you might mean. So you must avoid using the word amount. Instead, talk about concentrations, volumes, and masses. If it's a solid, it's going to be a mass. If it's a liquid, it's going to be a volume. If you're talking about, we shouldn't say strong or weak, but if you're thinking how strong or weak that chemical is, the word you're looking for is concentration. Then finally, just like we've always done in our practicals, you don't ever just do it once. Always put a little sentence at the bottom, repeat the investigation 3 times and calculate an average from the results. Okay? If you include all of these things every time, you're almost guaranteed to get full marks. But at the beginning of the question, they will give you instructions. They might give you bullet points, just like you've seen in your ICES, in your controlled assessments. Things that you can literally tick off to make sure you've included them. It's probably time to think about example questions. What would the question look like in a real exam? And how much would I actually have to write to make sure I've covered all of those 7 bullet points? Let's just recap what they were. Measurements. At least 2 measurements. Something that you're probably going to change, something that you're going to have to record in a results table, being very exact. What exactly are you going to measure? When exactly are you going to start your stopwatch or stop your stopwatch? Make sure you're using the correct names of apparatus. Is there a variable that you've got to change? Simply state you're going to repeat the investigation but changing that variable. Everything else must stay the same. So simply state, but give specific examples. If you're talking about an acid and an alkali and you've changed something about the acid, then simply state you're going to keep the volume and the concentration of the other chemical exactly the same. But do say what it is. You've got the words in the question, copy them. Finally, repeat it 3 times and do say that you're going to calculate an average with those repeats. Right, looking at a question, let's look at that massive load of space you see and let's try and get over that this isn't difficult. We're going to get 6 marks.